Okay, so good evening and welcome to our MBSE podcast. And this time, Christian and I are doing a new episode of our series MBSE Around the World. After Sweden and then China, this time we visit the United Kingdom and we want to see how MBSE is doing there. We are happy to have Jon Holt as our guest. And I think no one can tell us better about it. So, and who Jon is, he will tell you best himself. So please, Jon, introduce yourself.
Okay, thanks very much, Tim. And first of all, thanks to Tim and Christian for inviting me along. It's a pleasure and an honour to be with you. So for people who don't know who I am, my name is Jon Holt, and I've been doing MBSE for my whole career now, so for almost 30 years. I work for a company called Scarecrow Consultants Limited. We're based in the UK. I'm personally based in Wales in the UK. So for those of you in Europe, Wales is the slightly wet country to the left of England. For those of you in America, it's near London somewhere. I'm also a professor of systems engineering at Cranfield University here in the UK. And if people are aware of INCOSE, the International Council on Systems Engineering, I'm the current technical director of INCOSE UK. And I've authored 17 books on model-based systems engineering and its application in over the years. So that's a very brief introduction to me.
Wonderful. Yeah, thank you, Jon. So also from my side, a very warm welcome. And yeah, as the technical director, you for sure can tell us in which industries in the UK is systems engineering or maybe already model-based systems engineering used?
Well, it's interesting because I think the same as many countries, historically, systems engineering and therefore model-based systems engineering has been very strong for decades in aerospace and defence. But what we're seeing now is lots of other different industries coming on board. And I think one of the biggest ones at the moment is automotive. So, from about sort of 5 or 7 years ago, all of a sudden, automotive has become massive, and I think this is important because I think what's important about all industries, in particular automotive, I use those as the example, is because of the complexity of the vehicles, of the systems that they're producing, has increased so dramatically over the last few years, in particular in areas like everything is now connected. So every device we buy now is now connected. Everything is potentially part of a wider system of systems. And all of a sudden we've seen this sort of this step change in complexity because of that, and because of the different technologies involved, and because of things like constraints, so safety, security, standards, and so on, and also shifts in technology. So again, in automotive, away from internal combustion engines over to electric. It's been a massive change and a shift in complexity. And I think in order to cope with this complexity, I think the techniques we were using 10, 20, 30 years ago, a document-based approach, and don't get me wrong, there's nothing wrong with a document-based approach. It's not incorrect, but I think a document-based approach that worked 10 or 20 years ago is no longer adequate for the job because the complexity has increased so much. And I think as the complexity of our systems that we're developing increases, therefore the complexity of the approach that we're taking to develop those systems must also increase. And we're seeing lots of other areas as well. So automotive is a very good example, but also medical devices we're seeing now. The last couple of years we've been involved in that. Energy as well, so right from the whole spectrum, from sort of nuclear fusion, and we're even doing some work in steam power at the moment. So we're covering both ends of the spectrum of energy there. But yes, certainly we're seeing more and more diverse industries adopting model-based systems engineering, and very importantly, because it's the need that's there. It's not because it's the flavor of the month or it sounds good, it sounds exciting. It's because there's a genuine need there to cope with this increased complexity that we're seeing in all of our systems.
Mm-hmm. Wow, yeah, and for what purposes MBSE use? Now you can use it for different purposes. You can increase the communication within the team, and you can use it to specify things, or you can satisfy assessors with tons of generated documents. Now you can do already simulation stuff and other cool things. So is there a special focus in the UK?
Well, I mean, we work with all different industries and lots of different companies, academia and government, and it's been used in all sorts of different areas. And one of the things about model-based systems engineering is if you do a Google search on the benefits of model-based systems engineering, what comes up is lots of tool vendors saying, look what my tool does, look what my tool does. And they're not really the benefits of MBSE, they're things that the tool will do. And I think that the benefits of are sort of context dependent. So it really depends on the stakeholders you're talking to. So we can deal with the same organization. And if we deal with the engineers, we can say it's great, it's going to improve your specification, your design, your requirements, and so on. But if we say that to a manager, they're not interested. So if we talk to a manager, we'll focus on, well, it will improve your cost, time, and resource estimates. And if we're dealing with somebody at board level, we've got to focus on things like return on investment and improvement of the quality attributes of the systems. So it does vary enormously, but I think all of the topics that you mentioned there, Tim, are definitely, we've seen it used in all of those areas, but it really does vary. And as I say, we work with some organizations where different teams are getting different benefits from using MBSE, ranging from, one company, we want to halve up our development time. We want to go from a 6-year cycle to a 3-year cycle. And whereas others are, we want to improve our quality. But what is interesting is we're finding that particular industries are interested in, and this is a very broad generalization, but tend to be interested in different aspects of it. So it's interesting you mentioned quality. When we deal with medical devices company, their main emphasis seems to be on, can we comply with the standards and the legislation? Because if we can't sell our products. So for them, that's the most important thing. We deal with sort of aerospace type companies with typically long life cycles, and they're more interested in, can we shorten our life cycles? So it really depends on the stakeholders we're talking to, but we do see these trends in industries. We see a lot more collaboration now between organizations, whereas historically people were more insular. We see a lot more collaborations, and that's where areas like, Tim, you mentioned the improved communication between the different stakeholders, and we're seeing that an awful lot as well now. So, yeah, and I think it's because we work in lots of different industries that we can see these different applications being used. And I think if you were to talk to somebody who works in a single organization, which is most people, let's face it, they would give you a more definitive answer. This is how we use it. This is how we use it. And one of the big areas that we do use it for across industry is in defining an approach to model-based systems engineering. So actually using the modeling, using an MBSE approach to understand what their business needs are, to help them change the business. And, my personal philosophy is, when it comes to deploying MBSE, I treat that like a system. So of course I'm going to apply MBSE to do that. And that's a really interesting area that's a lot more prevalent now than we saw, just a few years ago.
And can you estimate how well MBSE is used in the different industries? So is defense and space still decades ahead, or is it changing?
No, I really don't think they are anymore. And I think that one of the reasons for this is, if we take industries like automotive, medical devices, the life cycles are far shorter. And so they need to get in quicker and get the returns far quicker. So, some of the automotive companies we deal with, they're going from a blank piece of paper to a car rolling off the production line in under 2 years. You look at a typical aerospace project, they haven't even looked at the requirements in the first 2 years, let alone produced anything. So we've seen these far shorter timescales. But I also think the maturity with the adoption of MBSE is increased dramatically as well. So as I said, I've been doing this for my whole career, even though it wasn't called MBSE many, many years ago. But I remember the first INCOSE event I attended was the International Symposium in 1999. So it wasn't even this millennium. That's how long ago it was. And it was in Brighton in the UK. And that's when I first got involved with INCOSE. But I used to speak at a lot of conferences. So we're going back 22 years now. And the big argument I would have with people, and the big point I was trying to convince people, is modeling is a good idea. And people would throw things at me and they'd argue with me, and it got very heated. But it was, and the first book I wrote, which was very, very slim, was actually, it's pre-SysML. It was called UML for Systems Engineering. It was applying UML to, and people were getting very cross about that. But the whole point of the book, the emphasis was on, this is why you should model. This is why modeling is a good idea. And then we found about probably 15 years ago, the question changed, and it went from why should we model to how should we model. And so there was a lot more acceptance about modeling. So, so if you look at the books that we were writing 10 years ago, we've got one called The Monster, which is like 1,000 pages long, that weighs more than a fat baby, essentially. It's an enormous, great book. And because the question had changed, and what people wanted to know then is, how do we model efficiently and effectively? And so there were a lot more interested in things like frameworks and processes and these kind of, and the art of modeling as well. And what we found in the last probably 3 to 5 years is the emphasis has changed again. And now the emphasis is very much on, well, how do we now deploy this in our organization? So I think the maturity and the adoption of MBSE has increased enormously over the last couple of decades. And I think as the adoption increases and the maturity increases, then the needs of the people using it also increase. So now it's a lot more about, well, how do we deploy it on a project that's already running? You know, that's midway through a project. Can we still get benefit? How do we deal with our people, process, and tools now? So I think the question has changed, but certainly the adoption is far more widespread. And in terms of the number of people, it's certainly increased. But again, I mentioned INCOSE again, and I use INCOSE in the UK as a good indicator. If you went back 10 or 15 years and you looked at the companies typically attending our what's now called the annual Systems Engineering Conference, the ASEC, and I'm sure you'd see a similar pattern across the world, it was 80-90% aerospace and defence. And it's no longer the case anymore. We're seeing all sorts of different companies getting involved now and getting involved with INCOSE. So we have the UK Advisory Board here, and that's a group of about 40 companies who are almost like a steering committee for INCOSE UK. And you look at the diversity on those companies now, we've got civil engineering companies, we've got IT companies, as I said, automotive, medical, power, a lot more academia involved now. So suddenly the adoption has become far more widespread. And because of that, the questions that are being asked have become a lot more widespread as well. And I'll say that's certainly the picture we're seeing in the UK at the moment. And certainly just in terms of the number of clients that we have now and the diversity of them, that's certainly increased.
Yeah, it's interesting that in your new book, you only need 445 pages to demystify systems engineering.
Yeah.
Well, the reason for, you see, we wrote The Monster, and which was enormous, and then people were saying, yeah, we like it, but I can't show that to anybody. There's just too much. There's too much. So then we wrote a thing called Don't Panic, which is a very slim book, which is only 55 pages long, which there's now a whole series of these books published by INCOSE UK. So that was aimed at the new people and the managers. So the demystified kind of sits between the two. So it's more detailed than the Don't Panic, but it's not quite as mind-numbing as the 1,000-page monster. And of course, if you've got somebody that operates at board level, we've got a book for them as well, which is the children's book that's aimed at 8-year-olds to 11-year-olds, which is more. And if they don't understand the engineering, they can just colour it in. So that's aimed more at people at CEO level. But there we go. But yeah, so the Demystified book's an interesting one. And I was approached to write that by an Indian publisher. And again, it's interesting because although it's sold across the world, obviously the demand was coming from India. And it's interesting, we were talking before about India and China and you know, the adoption of engineering in certain countries. And yeah, we've just seen a far wider audience. And also because of who I am, if somebody asks me to do something, as you now know, I can't say no. I have to just agree to it because my ego won't let anybody else do it. So this is why I end up taking on lots of these projects and committing to all sorts of weird talks and things that I wouldn't ordinarily. So when they approached me to do it and they said it was aimed at this particular market and people who are new to the field but wanted some detail and wanted a case study going all the way through it. So there was quite that strict, but they had a very good set of criteria that had come from their marketing department. And again, that was interesting because the marketing was predominantly done, as I said, in sort of India. So, and it's interesting seeing these countries really take on board systems engineering, and in particular model-based systems engineering. So I think that's a very encouraging picture for MBSE globally.
I bought your book, but I must admit I haven't read it yet.
I don't care. As long as you buy it, Tim. I couldn't care what you do with it.
But the title, Demystifying Systems Engineering, sounds a little bit like you, again, try to answer the why question. So why should I do a systems engineering?
The demystified it is really that's more from the publisher. I think it's a good title, obviously, but they do a series of books called Demystified, which are aimed at this particular. And it's kind of like, so in INCOSE UK now we have the Don't Panic books, which are set at a higher level. But yeah, so when they approached me and they said, this, and they sent me examples of what some of the other ones were, but they were all about coding, so I couldn't really read them. But they were so that. So the title of that, and that was one of the things that they kind of came up with. But apart from that, they gave me quite a lot of freedom in the book to write what I wanted. So it was a very good process working with them, and writing with them.
I took a short look into it, and it was interesting for me that you are referring at the end or at the beginning of every chapter to how does it comply to ISO 15288.
Well, so, I think. To me, the provenance of engineering is very important, and I think demonstrating compliance is very important. And I think increasingly for a number of industries now, and I'm the first to admit things like ISO standards aren't perfect, but it gives us a good target to aim for. And one of the problems you'll get is with model-based systems engineering. People want to say, well, how does it relate to the way that we do things already? Or, how can it solve these problems for us? So that was a very deliberate part of the book, is wherever possible, are related. And it's something that we reflect in our working philosophy anyway. We try and relate it to what's acknowledged as sort of best practice. And in the world today, so the two big standards we use in the book are obviously 15288, which is more of the process side of things, but also the 42010 and the associated standards, which are more about architecture and architecture framework. But we use those as a central part, obviously, of all the modelling that we do, because when we do modelling, a large part of the book is advocating creating a good framework for the model. And so, again, we want to reference that to best international practice. And I think the two standards work well together. As I said, then the standards aren't perfect by any means, but they're a really good best practice model. They're acknowledged across the world, and it just gives you that extra level of credibility. Because I know from experience, people will say, yeah, but we do things like this already. How does MBSE help us? So it's trying to preempt that question, if you like, and say, well, here's your best practice model. You can use it to do this. You can use it to do this. But what that also allows you to do, which is very interesting, is, I don't need to tell you two about things like reuse, but for lots of people who don't have a modeling background, this is quite big news to them. And when you can say, well, actually, for this part of the ISO standard, remember that thing we did a while back and we produced these views in this model, we can reuse those for this part as well. So things that we did in requirements and we were doing scenario modeling and things like that, we can reuse those now as part of our acceptance testing that we're now using as part of our V&V. And so it allows you to do things like that and to make these references back. And I think that's very important as well, because I don't want to get too much into reuse, but reuse is one of those things that I remember back in the sort of mid 80s and early 90s, everything was about reuse and object orientation, and there were a lot of myths and a lot of expectations that weren't quite met. But from a modeling point of view, I think reuse is very, very possible when it's done properly. And so I think that was an important point that we wanted to make as well. And again, the use of standards gives us a good mechanism to show that, particularly when it came to, so there's one chapter on management, for example, and almost all the views that we create in management are based on the engineering views. And that's a nice exercise to do. And that's a point that we're often trying to make to people as well, is why do we have these two completely separate disciplines that won't talk to one another when actually we're all looking at the same thing? And I think this is a classic problem that we have in systems engineering. To me, one of the biggest problems that we have with systems engineering is the word engineering, because it scares people away. Because people will say, well, I'm not an engineer, I can't possibly understand what you're talking about. We do things differently. Whereas if you say systems thinking or a systems approach, oh, everybody wants a systems approach. Everybody wants to do systems thinking. But yeah, you say systems engineering and people run for the hills screaming, so which can be a bit of a problem.
Yeah, I also have more and more customers asking for ISO. I think ISO provides some more stable areas in this very dynamic environment, so it feels a little bit more safe. So many people ask me how to map SysMod to ISO and the SysML and the ISO standard and this is standard and so on. So that's very interesting.
And it is, and people like the comfort of ISO as well. We used to have an expression in the UK, I'm sure it was worldwide, that said, nobody ever got fired for buying IBM, right? I won't comment on how valid that is as a statement now, but it's that same philosophy, which is, well, if you're referencing ISO, you're not going to get into trouble for, complying with an ISO standard. Oh, that was my cat just leaping up then, he's not a big fan of ISO. As soon as I mention that, he leaves the room. So.
I thought, it was also very interesting what you said about the maturity of MBSE. And I think, well, in the past, tools and methods could do much more than the people needed. But I think now we are in a change, and today people need more than the tools and methodologies can provide. So
I couldn't agree more with you, Tim. Absolutely. And I think for so many years, I will say now, this is my personal opinion and not aimed at any particular tool vendor. But for so many years, we had tools that were doing so much stuff that nobody would ever use and was never required. I mean, who's ever wanted shadows on their lines on a diagram? And this sort of insanity and all these different techniques and all these that people, marketing people tried to convince us we needed, and we, just give us the basic functionality. But I think for many years, all the tools were way ahead of the game and were providing functionality that people weren't using. But I think suddenly now, the last 5 years or so, I agree with you, Tim. I think now the tools are playing catch up. And I think in some cases they're focused on the wrong areas. But I think also, like I say, we're living in a connected world. I think this idea of a single vendor, people are finally realizing is not particularly realistic, particularly when you work in a big organization. When you work in a large company, you're going to be using multiple tools from different vendors. And I think one of the biggest issues at the moment is tool interoperability. So actually, you're using a requirements tool from one vendor, you're using a SysML modeling tool from another vendor. We've then got a PLM environment that somehow sticks all this together. We've got the mathematics and the simulation side of things, and we need all these things to work together. And I think at the moment, most of the tools that I see on the market are shockingly bad in this area of tool interoperability. And I think particularly in areas like the visual world of SysML, compared to the formal mathematical world of simulation. And, we've got mechanisms in SysML that give us that bridge, so things like parametrics give us a natural bridge into those. But I think many of the tools at the moment are terrible, to be quite frank, in that area. And I think this is an area that needs to have a lot of improvement. And I also think that you look at some tools and the usability of them. If you went back 10 or 15 years, it was the same with many industries, but software in particular. Software was telling you what you wanted. The vendors were saying, no, you should do that. You want to do it like this, you want to do it like this. People aren't that willing to accept that anymore. And I think using something we did speak about briefly earlier, Tim, but, using a tool with an interface that's 20 or 30 years old and hasn't really moved on is no longer good enough. And I don't think some of the vendors realize that usability is such a big issue at the moment, because it really is. And again, I would rather that the vendors focused on making the core functionality very usable, user-friendly, and compatible with other tools and so on, than having the equivalent of wingdings on a modeling tool, which is essentially what they're doing in many cases. But yeah, and you think any other software, if it had an interface that old, you wouldn't you wouldn't go near it. But But I really think that's a big issue. And to my mind, I think they're the two biggest issues I have with them. The first one at the moment is the whole interoperability of the tools, and also the usability of them. And these things aren't cheap either, as we've discussed before. And they seem to be getting more expensive as time goes on. And I think that the responsibility is on the vendors now to actually produce something that's more fit for purpose than many of the tools are. So that's as diplomatic as I can be about tools.
Yeah, we have 2 comments in the live chat this time. So
okay.
One recommendation for your book, that it's a great book, by the way. And we have a comment from
Thanks, Mum. She always joins in on these podcasts.
And we have a comment from Mark, who suggests that we just have to rewrite the standards as models.
Well, this is a really important point, and it's something that I've spoken to ISO to. I've been involved with ISO for a number of years, for years and years and years. And one of the ways that we demonstrate compliance is we model the standards. And again, anybody with any modeling knowledge will know that just the very act of modeling gives you a very good indication on how well written something is. And if something's very well written and well specified and you model it, the model just falls out and it's easy. If it's difficult to do the modeling, if there's a lot of ambient, it tells you about how badly written the source information is. And we've been doing this for years and years with, in fact, one of the first, what we now refer to as the sort of frameworks we use and so on. One of the first ones that we produced back in fact, I'll tell you how long ago it was. I mentioned the first INCOSE conference I went to was in 1999. The paper I presented was on using UML to model standards. Right. So, and because standards were so look at standards, look at best practice models. There's hundreds of them. They're very complex. They all use different language. They're difficult to communicate with people. People don't understand them. It's the perfect candidate for modeling. It ticks all the modeling boxes why you need to model. And why people don't define standard using models is beyond me. And I've spoken to not just ISO, to different standards bodies before as well, to say, you should be doing them like this because it makes them far less ambiguous. It makes them easy to communicate. You can translate it into different languages far easier. And I think that's so Mark, I love you, Mark. That was an excellent point. And I couldn't agree with you more. But also when it comes to compliance, if we model our own processes and frameworks using the same modeling techniques that we then model our standards with and our best practice models, the compliance we can build into the models then, and we can actually import them into the tools, and the compliance is then built into our overall model. So, and to me, it's so obvious, yet so few people do it. And I think that's a really, really good observation there from Mark. Very good comment.
By the way, we started creating a document generation from the model for the SysML1 specification, and we found many inconsistencies in the specification. And the previous SysML1 versions and also the UML versions are, well, partly they're modeled, but most of the stuff is pure text document.
And and you see this in so many standards, and particularly if you do any work in frameworks and things like the defense-based architectural framework, so the MODAS, the DODAS, the ZINDAS, the NAFs, and so on. If you just do the most basic of modeling on those, and they expose themselves for the bag of spanners that they really are. So yes, but model standards, model best practice references, whether it's in-house procedures, whether it's framework definitions, and it will give you all sorts of insights into what you're doing. And it gives you just a really good indication of how good the source material is.
Yeah.
Yeah, we have a very interesting discussion in the chat about interoperability, and I guess we have to have it as an own topic on another day. But
definitely.
Yeah, absolutely. But for now, I would like to change the topic a little bit on your professorship. So you're teaching systems engineering. You're teaching at a university. Is it the only university where you can have systems engineering lessons, or is it wider spread? And what do I do when I'm a professional? And
it's clear that it's the best taught systems engineering in the UK, if not the world. But apart from that, we've seen an increase in the number of universities that are offering systems engineering. And more important than that, we've seen a big increase in the quality. And I think it's fair to say, if you went back 10 years and you looked at universities, not all, but some universities, they would look at systems engineering and go, well, we'll just take a bit of mechanical, a bit of electrical, a bit of civil, a bit of software, or a bit of management, or we'll mix it all together, and out comes a systems engineering degree, for example. Mm-hmm. And so what we're seeing now is actually, and to me, that's kind of a master of none kind of approach, you know. But what we're really seeing now, the last sort of 5 or 10 years, is universities creating these courses from scratch and then bringing in other modules, obviously reusing from other as and when, but actually they're really holding very well together as systems engineering courses. When it comes to modeling, and a problem that I've often had with which is good news for me, because one of the things I do in Scarecrow is I teach modeling, is people are leaving university and they've been taught something like UML or SysML, but they've been taught by somebody who's never used it in anger. They've been taught by somebody who's read the spec and understands it and understands modeling. But you know, as you'll both know, there's a big difference between understanding what the diamond means and should it be coloured in and not, and actually applying this onto a real project. And I think that's very interesting, and that's what we've seen a lot of now. And I think also, to be fair, it's why I was offered my position in the first place, or one of the reasons it was offered, apart from the good looks, was because I had lots of industrial experience, and they wanted to bring that into the course. And I think that's very important as well. So we've seen a lot more systems engineering being adopted, and we're also seeing a lot more now that the default is modelling is involved in it somehow, even if it's not, you know, full, what I would call sort of stage 5 MBSE. This modelling is an increasingly important part of what we're doing when it comes to systems engineering. So I think the education system is improving. And we have some working groups within INCOSE UK to look at this. And in fact, I do work with, I've mentioned very briefly the children's book that we wrote, but we have what we call STEM in the UK. So STEM is science, technology, engineering and mathematics. And so it's really promoting things like, for me, obviously, it's all STEM, but secretly the E part of STEM to school children. So I'm also involved in doing, well, I say I'm involved. I haven't been for the last 15 months for obvious reasons, but I used to do a lot of sort of evening lectures and science festivals, music festivals. I've got a music festival coming up at the end of July. So what I also do, which you probably most people don't know, is I do. I'm also a magician as well as being a systems engineer. So I do science and music festivals where I use magic to communicate systems engineering to people. So we can talk about all the things we talk about in modeling, good communication, looking at things from different points of view, visualization, all these kinds of things. So visualization, the things that we would think about in SysML, you can use as a basis for doing memory acts and things like that. So I can memorize a deck of cards using the same visualization techniques I use to model, you know, a car or an aeroplane or a medical system. Mm-hmm. So there's a lot more work being done trying to get into younger, to convey engineering, in particular systems engineering, obviously my emphasis, to the younger generation as well. And because obviously you want to get them before they go into university, so try and get them excited and kind of inspired in some way. And I think that's very important. And we're starting to see some of that come through now. And it's also a sign of getting old as well. When I meet an enormous man, for example, or a full-grown woman, and they say to me, "Oh, I saw you when I was a child at a school," it makes me feel happy inside, but old on the outside when that sort of thing happens. So I think it's important that we can, yes, get it into universities and yes, improve the way we're doing that. But I also think it's important that we can go before that and get children, you know, at a younger age, because everybody's naturally curious about things. And, you know, you mentioned engineering, people switch off. You mentioned problem solving, everybody gets excited, you know, and what's engineering if not problem solving? And we do it by, you know, at the simplest level, drawing pictures of stuff. And that's naturally how people work. That's naturally how people think. And for some reason, that gets driven out of people's minds to naturally think in images and visualize things. as we go through the education system.
Would you say that there's something special about MBSE in the UK compared to other countries, except Jon Holt?
Well, yeah. This is what I
That's special.
I don't know if it's particularly special in the UK. I think many countries, it's a big stereotype, but many countries have a particular mentality as well in the way that they go about things. And what I've seen in the UK is these mentalities can be associated with industries. So again, I mentioned aerospace, if they were early adopters of systems engineering and model-based systems engineering, but they, again, broad generalization, far less open to new ideas than you get automotive medical devices. They're coming to the party late, but they're having a very good time when they get there. And they're a lot more receptive to try and change the way that they work and so on. And I think that's the big thing, to me, the big blocker with MBSE. It's the people, we often talk about people, process and tools. It's the people side of things, and it's winning that battle with people. It's getting them to be able to see for themselves, rather than just tell them, do it this way, it's great. Getting them to see for themselves and realize that actually this is a good way to do things, and there are benefits in it for different people. So it's that attitude change, and I found that that's more to do with the industries than sort of geographically where we go. And it can also be, a younger generation coming through tend to be more open to new ideas than, and I include myself in this, old, white, middle-aged, straight men, essentially, which is what the industry is full of at the moment. But as we see more diversity from, in all different areas coming through engineering, because I still think we're behind on this, but I think a natural emergent property of diversity is people having a more open mind and people being more receptive to, maybe slightly different or newer ideas than people of older generations. And I think that's very important. So I think the future's very bright, and I think that's what we've got to focus on, is look at the future and say, yeah, can we inspire the next generation of engineers? And wow, what is it possible they can achieve that just with a more open mindset and with opening up their eyes to these different techniques? So things that have been taking me 30 years to shout at people and finally get them to convince. What about people who don't have to do that, who can just try out these new ideas and new areas, and the potential has got to be enormous across the world.
Yeah, one very funny thing is, if you follow Scarecrow Consultants on LinkedIn, is that you publish every week a riddle, a similarity on song titles expressed in a SysML diagram. So
we've I like puzzles, I like terrible jokes, I like music, I like films. So there's a very popular sort of parlor game that's called Pictionary, which is like picture dictionary. So you draw pictures that represent films and so on. And so it started off as a bit of a joke where it was, when I do courses and conferences and things, and I would say, you can represent any information using modeling, because it's just a way to visualize things. And so people would say, can you do this? Can you do this? So it started off as a bit of a joke doing things like that. But no, we do it every Friday now. So it's usually a film or a song. So if it's a film, it might be the film title, or it might be. So this week we've actually got a scene from a film that we've done with a sequence diagram. And so we use SysML to visualize either the title or some of the lyrics of a song or whatever. Occasionally we'll do it for people. Very occasionally we'll do it for a type of cheese. So it really depends on what we do. But we've got quite a big following on this now, and it's interesting. Wherever I go, wherever I used to go, and will hopefully be going again soon, people come and approach me. And, I was in America, for example, a few years ago, and Rick Stein came up to me and he says, every Friday we gather the whole research group round and we all see who can get it first. There's a bit of a competition going on. And it's really fascinating. You just go, what, really? That terrible puzzle that we do every week? But it's great, and it gets people interested, and very occasionally people say they learn a bit of SysML from it as well. But I think it's getting people thinking in an abstract way. And it's not just about designing the new aeroplane, the new car, the new train or whatever. You can use these techniques to convey any kind of information. And in fact, it was Rick Stein that said to me, which really stuck in my mind, he said, well, you can only truly master any language if you can express humor in it. And he said, and that's what SysML does. So he uses that as an example to some of his students. And I think that's very important. So if you do go onto our LinkedIn page and you do this, you have to go with an open mind, and bear in mind there are some terrible, terrible misinterpretations of song titles and things like that on it. So, but yeah, so we do that every Friday. It's a good fun thing. So come along and join in if you do. And if you're very lucky, you might even have it dedicated to you 1 week. That's the goal, Tim.
Yeah, last week. It reminds me of a great film. Very good. Is it correct that you published some of them in a book? I think I saw it somewhere.
So when we go to conferences and things, so we'll collect like a year together and just print them in a book, and we can. We normally give them out just as like a free thing, and people tend to like it, and then we give them out as prizes and things like that as well. But then we print them through an online publishing company, and so just for a joke, Simon, one of my colleagues who I write a lot of the books with, he said, "Oh, we'll just put it up for £5 and see if anybody's stupid enough to buy it." Somebody in Canada bought 50 copies. So. Hey, fool with money, as they say.
Yeah.
Ain't hardly a fool at all. But no, so we do so people want the hard copies, just send me an email and we'll send you some out. So we give those away at conferences and things like that. We don't normally charge for those. But it's normally just like the last year that we've done and put together. And it's kind of nice to have them in your book. And you can kind of
copy it from LinkedIn or so.
Yeah. So come and see us at the next conference, and you can have a signed copy with a personalized message in SysML, especially for you. So.
What's your next conference?
The next face-to-face one I'm doing is hopefully the INCOSE UK Annual Systems Engineering Conference in November of this year. That's obviously takes place in the UK. I'm heavily involved in that because I'm the technical director, so I'm responsible for getting all the papers reviewed and all the technical content. So that'll be the next one that we're at. I'm appearing at quite a few online ones over the next 12 months as well. I've got quite a few German events coming up, actually. You're the first of many German events that are coming up. So if you like this, come and see me at some of the others. I'll be saying the same thing, but with slightly different hat on, maybe, or something like that. But yeah, so there's quite a few coming up. I mean, one of the good things about COVID is I get invited to a lot more international conferences than I used to. It's not quite as nice sat on my sofa and imagining that I'm in Paris I was supposed to go to Paris as one of the keynotes in December at Christmas time. I thought that would be great, and take my girlfriend, we'll have a lovely time, and we didn't. So instead we sat here and drank red wine on that evening and pretended that we were in Paris. So not quite the same.
Yeah, sounds good.
Great.
Okay, so we are live for now 42 minutes. That's a good time.
Correct. And I have still 3 tasks for our listeners. The one is give us a thumbs up on YouTube so you can support the channel. Don't forget to subscribe to the channel so you don't miss out the next live stream. And last but not least, buy the book of Jon, the new book.
Not just that one, all of them. All 17.
All of them. Okay.
17.
Okay.
Yes.
So
but buy all 17 of them. I'll give you a free SysML. How about that?
Great. Yeah. And Tim.
Well, then the next topic is not planned yet. We have some ideas, but we have no next topic, no date yet. And it's also a little bit summer break time. But, well, we will do something, pretty sure. And, well, I think that's it so far. Huh?
Well, I'd just like to say thanks to both Christian and Tim for inviting me on. It's been a delight. And I'd also like to say very sincerely, good luck in the football tomorrow night to you two and everybody in Germany.
So now you have to watch the YouTube video if you are just listening it to see what John really meant. Yeah,
we could spoiler the result for tomorrow. I know it.
Yeah, John, also from my side, was an honor to have you here.
Thank you very much.
Thank you very much.
Okay, I look forward to seeing you both in person in the next year. So
yeah, definitely. Okay, so good. And well then, do not forget.
Trust us. We are systems engineers. Good.